फ्रेंड्स, तो डिस्क्रीट मैथमेटिक्स में हमने यूनिट 5 में हमने किया है ग्रेडियंट, डाइवर्जेंस, कर्ल। और उसके बाद हमने लिया था लाइन इंटीग्रल के बाद हमने उसके एप्लीकेशंस मैंने आपको बताया था। लाइन इंटीग्रल की डेफिनेशंस हैं इन ग्रीन्स थ्योरम, स्टोक्स थ्योरम। तो पहले हमने लिया था ग्रीन्स थ्योरम और आज हम लेंगे स्टोक्स थ्योरम। ओके, तो स्टोक्स थ्योरम क्या है, what is that? So let's take the statement of this theorem. So this theorem states that the surface integral of a curl of a vector is equal to, the curl of, you can take the curl of a vector. Okay, generally we are taking the curl of a vector field. So that is equals to the line integral of the vector enclosed by that surface. If you have given a surface as that is enclosed by this C curve, okay, this is the vector field A and this is the line, okay, line that enclosed a surface S. Okay, then the surface integral of curl of this vector field is equals to the line integral of that curve. Okay, so this is nothing but this is the Stokes theorem and del cross A, and mathematically you can write this as del cross A dot ds is equals to the, this surface is closed surface, this closes this surface as line integral, this line is encloses this surface as A dot dr. Okay, and previously we have taken here f dot dr. So now next you can also write this as the surface integral of curl of a vector field A taken over any surface S is always equals to the line integral of vector field A taken around the bonded line C of that surface. Same concept is here that I have already told you how you have taken this surface as, if you have taken this vector field on a surface S and this surface S is enclosed by a curve C, this is a line curve. Okay, so now let's take the example how this is basic application of the line integral. Okay, so let's take the example. So verify Stokes theorem for vector field you have given this vector field f is equals to 2x minus y I minus y j minus y square z k over upper half surface of what is the equation? This is the equation of a, okay, this is the equation of sphere bounded by projection in xy plane. Xy plane. Okay, so what you have given and what you have to verify, the Stokes theorem, means you have to show the curl of this is equals to line integral of surface integral of curl of this vector field is equals to the line integral of this vector field, and over which surface, over you have given this surface, this is the you have line integral you have taken, and the over which surface you have to taken, this surface is nothing but it is a surface of the sphere, and only the upper half surface is given to you, that is in projection in xy plane. Okay, upper half surface, and that is given to the projection. Okay, upper half surface in xy plane. Okay, bounded by projection. This, so let's take what you have given solution. Now here C is the circle in xy plane. Okay, and you have z is equals to 0 here, xy plane. You can take z is equals to 0. How you can write? If you have given this, see, this is the three-dimensional figure, x, y and z. Okay, you can take this. Now see, if you have the upper half surface in xy plane, okay, you have given this xy plane, so I am taking here xy plane. Okay, upper half surface means you have taken only this. Sphere is like this. Okay, if this is a sphere, okay, if you have given this sphere, if a plane cut it in a circle, so that is a circle, equation of the circle, and upper half surface of the sphere is this one. Okay, and if you have taken this only a circle, means this circle is this, and this is the plus, this is a minus a0, and this is a0, and this is nothing but ab. Okay, so this a0 is this thing. Okay, 0a is this. This is the radius of the circle. Okay, so C is nothing but it is a circle in xy plane with z is equals to 0, and S is the surface of sphere. Okay, S is given to you, that is the surface of the sphere. Sphere, equation of the sphere is this, z square is equals to 1 is upper half surface. Okay, only the upper half surface of the sphere. Okay, now you know that. Now you have to take an f dot dr. F dot dr, what is that? You have given f is given to you. So what is f? Or you can take the line integral in xy plane, that is f dot dr. That is f dot dr means f is equals to 2x minus y, dr you know dx. R is equals to xi plus yj plus zk, then dr is equals to dxi plus dyj plus dzk. Okay, this is dx minus yz square dy. It is your yz square. Okay, yz square dy. Then next is minus y square z dz. Okay, this is nothing but this is the equation. You have taken this line integral. Okay, now one concept is in up xy plane, and in xy plane z is equals to 0. xy plane means z is equals to 0. Okay, and this is, if you have given this circle, then what is your x and y? This is x and y. X is equals to, this is cos theta, radius is 1, y is equals to sin theta, a sin theta, a is equals to 1 here. So you are getting here f dot dr is equals to z is equals to 0, dz is equals to 0. You put these values here, you are getting 2x minus y dx, simply this. And this is, now you know the circle in polar coordinate, so this, and theta varies from 0 to 2 pi. Okay, so now change this Cartesian to the polar coordinate. Okay, so this is 0 to 2 pi and 0 to 2 pi, and now take 2x is cos theta minus y is sine theta. And what is dx? Dx is nothing but minus sine theta. It is minus sine theta d theta. Okay, d theta. Now solve this integral. Simply you have to solve this integral to cos theta sine theta minus sine square theta d theta, and negative sign is here. So what you are getting? Solve this sine 2 theta 0 to 2 pi minus 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 plus sine square theta. Convert this into the cos theta 1 minus cos 2 theta divided by 2 0 to 2 pi d theta. Okay, solve this integral. So what is sine 2 theta is cos 2 theta, that is minus cos 2 theta minus minus plus upon 2. Okay, 0 to 2 pi plus 1 by 2 0 to 2 pi theta minus cos is minus cos sine 2 theta divided by 4 0 to 2 pi. Okay, so finally what you are getting? Cos 2 pi. Okay, cos 4 pi is nothing but cos pi minus 1 and cos n pi. Okay, you know this value, cos n pi is equals to plus minus 1, means for n is even it is 1, for odd one it is minus 1. So 4 is even number, so its value is 1. 0 is also 1 by 2 minus theta 2 pi by 2 minus sine 2 pi and pi 0. So what you are getting? So its value comes out to be how much you are getting? This is comes out to be pi. Okay, this value comes with the help of line integral. Now you have what is the question? Verify Stokes theorem. So how you can verify this? You have taken this with the help of Stokes theorem. Okay, so next just take Stokes theorem. So by Stokes theorem, you know that f is given, that is 2x minus y I minus y z square j minus y square z k. Now del cross f is equals to, you have to find del cross f, curl upon curl x, curl upon curl y, curl upon curl z, and what is this? 2x minus y z square or minus y square z. So find out this determinant. I have written this in this place. So find this determinant. I have taken here I, curl upon curl y, that is minus 2y z, curl upon curl z, minus minus plus plus y 2y z also, and what is j, curl upon curl z is 0, curl upon curl x is 0, because here there is no term z, no term of z, no term of z here. So x here plus k, so write down k, curl by curl x of minus y z square is 0, curl upon curl y is minus minus plus 1. So what you are getting? This is cancels out and you are getting k vector. Okay, you know this thing, k vector, you know, this is I, j and k. K vector is always perpendicular to I. It means x, y, z. This perpendicular to x, y plane. Okay. So by Stokes theorem, f dot dr, line integral of this is equals to the surface integral of curl dot n dot ds. ओके, क्या आएगा ये? कर्ल डॉट n dot ds. ओके, एंड this is nothing but this is your unit normal vector. Okay, so n is unit normal vector. So direct curl of f is nothing but this is k, and unit vector in xy plane is normal vector कौन सा आएगा? What is that? K. Okay, so this is dx dy. Okay, so this is your r along the surface r. So this is nothing but k square is equals to 1 and dx dy along the surface r. Clear है? So you know this I have already told you that if x is equals to r cos theta, y is equals to r sin theta, you have solved this integral and you are getting here a is nothing but r is nothing but that is n. So surface area, this is represent the surface area. Surface area is nothing but pi a square. Pi a square, a square is 1 square, that is pi. Okay, from 1 and 2, see 1 is this, let it be your 1. Okay, and let it be your 2. From 1 and 2 and 2 we have f dot dr is equals to the surface integral of curl of f dot ds. Hence Stoke's theorem verified. Stoke's theorem verified. Okay, so this is the verification of Stoke's theorem. जो भी questions आएंगे, you have to that questions in the similar manners. Okay, there is some difference between the geometry. Okay, geometrically there is somewhat difference, but otherwise all the problems are alike. Okay, let's take the DHA question. Then you have solved that question by yourself. Okay, so verify example is verify Stoke's theorem for the function f is equals to x square I plus xyj. Okay, integrate round the square in plane z is equals to 0, where sides are x is equals to 0 and z is equals to 0. Okay, so this is the question that you have to prove. You have given this f. Okay, f is given, means vector function you have given. Verify Stoke's theorem. So first of all, f dot dr is equals to curl of f. Okay, ds. So this you have to prove. First you have taken that line integral. Okay, line integral for the which surface you have f dot dr for the x is equals to a है. I think x is equals to x y z is equals to 0. X is equals to a, y is equals to a, and z is equals to 0. So first you have to plot this. Okay, a b c d. So what are, this is the distance a. X is equals to a 0. This is nothing but a, and this is 0 a, and this is 0 0. Okay, so you have to find the line integral along the direction AB, BC, CD and DA. Okay, f dot dr along the curve C is nothing. F dot dr along the curve AB plus BC plus CA plus CD and plus dA. So first you have to find, see, vary in from A to B. A to B is x is constant and y is vary from 0 to A, and x is constant. From B to C, x is also constant, and y varies from A to 0. And C to D, uh, x is constant and y is constant and x varies from A to 0. X varies from. Similarly, DA, here x is constant, y is constant and x varies from 0 to A. Okay, so you have to find this integral, then verify the Stokes theorem. Just find curl of f dot ds. Okay, so if both results are same, means your Stokes theorem verified. Okay, do this question like this. Okay, thank you students.